Hello students, let's come to our channel Learn and Gain. So here the question is find the zeros of the following quadratic polynomial. So and verify the relationship between the zeros and coefficient here. In this question we have to find out the zeros of the quadratic polynomial and also verify the relationship between the zeros and coefficient. So they given 6 quadratic polynomials here. So let's come to the answer to this question. So we have to take the first quadratic polynomial, that is the first one. So given polynomial is x square minus 2x minus 8 here. So for this polynomial we have to write as a, so that is equal to x square. So minus 2x we have to write as a minus 4x plus 2x minus 8 here. So let's see here, minus 4x plus 2x. So after minus these two values here, we will get the again minus 2x. So that we have to write like this. So that is equal to, in this polynomial we have to common the common terms. In first two terms we have to common the x, then we will get x minus 4. So plus, in these terms we have to common the 2 here, so that is x minus 4 again. So again we have to common the x minus 4 and remaining is x plus 2. Now we have to equal to 0, that is implies x minus 4 is equal to 0 and x plus 2 is also equal to 0 here. Then we will get the zeros, x is equal to 4 and x is equal to minus 2 here. So from this information here, 4 and minus 2 are the zeros. So zeros of the given polynomial. So now we complete the finding the zeros. So now we have to verify the relationship between the zeros and coefficient here. So for this, so first one, so sum of the zeros, so that is equal to here, so from the above information, so let us assume that here alpha is equal to 4 and beta is equal to 2. So we have to assume that alpha beta are the zeros of the given polynomial. Then the sum of the zeros here, that is alpha plus beta, is equal to here. So 4 plus of minus 2, that is equal to, plus into minus we will get minus. So 4 minus 2 is equal to 2 here. The sum of the zeros is equal to 2. So now product of the zeros, so that is in the form of alpha beta, so that is equal to here. So here alpha value is 4 and beta value is minus 2, that is equal to minus 8. So this is the relation between the zeros here, that is sum of the zeros and product of the zeros. Now let's come to the second one. In second one, the given polynomial is, so 4s square minus, so here 4s plus 1. So that is implies 4s square. So here also we have to write minus 4s as a minus 2s minus 2s plus 1. So now next step is we have to common the common terms in it. So that in these two terms we have to common the 2s. Then we will get 2s minus 1. So here we have to common the minus 1. So here also 2s minus 1. So again in this polynomial we have to common 2s minus 1. So the remaining term is 2s minus 1. Now we have to equate to 0, that is implies 2s minus 1 is equal to 0, and so again 2s minus 1 is equal to 0. So we get the s value here. S is equal to, so minus 1 became a plus 1 after moving on right side. So that is equal to 1, and 2 in the division position, that is equal to 1 divided by 2. And here also s is equal to 1 divided by 2. So for this let us assume that here alpha is equal to 1 by 2 and also beta is equal to 1 by 2. So here 1 by 2 and 1 by 2 are the zeros of the given polynomial. Now we have to find out the relation between the zeros here. So that is first one, sum of the zeros. So alpha plus beta is equal to 1 by 2 plus 1 by 2. So here that is equal to 1, and now product of the zeros. So it is in the form of alpha beta is equal to 1 by 2 into 1 by 2. So we will get here 1 by 4. So this is the relation and the zeros of the given polynomial. Now let's come to the third one. In third one, the given the polynomial is 6. So 6x square minus 3 minus 7x. So this is the given polynomial here. So for this given polynomial is 6x square minus, so next x term that is minus 7x, again next constant term that is minus 3. So that is implied. So here also we can write minus 7x as a 6x square. So here minus 7x as a, so minus 2x plus, so minus 9x plus 2x, and here constant term minus 3. So that is equal to, so in these two terms we have to common the 3x, then we will get here. So here after common the 3x from these two terms we will get here, that is 2x minus 3. So here we have to common the plus 1. So here also 2x minus 3. So from this polynomial here we have to common again 2x minus 3. So remaining is 3x plus 1. So that is 2x minus 3 is equal to 0, and here 3x plus 1 is equal to 0. Then x is equal to, so minus 3 became a plus 3 after moving on right side. So and 2 in multiplication position in left side. So it became a division position after moving on right side. So 3 divided by 2 here, and here Same process, x is equal to plus 1 became a minus 1 and 3 divided by position here, that is minus 1 by 3. So from this information here 3 by 2 and minus 1 by 3 are the zeros of the given polynomial. So now let us assume that here alpha is equal to 3 by 2 and beta is equal to minus 1 by 3. So from this here we have to find out the relation between the zeros. That is the first one, sum of the zeros here, that is in the form of alpha plus beta is equal to alpha value 3 by 2, so plus beta value minus 1 by 3. So that is equal to here. So 3 by 2, so plus into minus 1 by 3 here. So that is equal to, we get the value. So LCM is 6. So LCM is 6 and here 9 minus 2, that is equal to 7 by 6. So this is the sum of the zeros and here product of the zeros is, so product of the zeros, so this is in the form of alpha beta is equal to alpha value 3 by 2 and here beta value minus 1 by 2. So in this, so minus 1 by 3 here, in this 3 get cancelled, then that is equal to remaining is minus 1 by 2. So this is the relation between the zeros. So now let's come to the fourth question here. So in this the given polynomial, that is, so given polynomial is, so 4u square plus 8u. So that is equal to, we have to common in these two terms, that is here 4u, then we will get u plus 2 here. So u plus 2 here we will get. Now here we have to equate the 0, that is 4u is equal to 0 and u plus 2 is equal to 0 here. Then u is equal to 0 and u is equal to minus 2 here. For this we have to find out the zeros, that is 0 and minus 2 are the zeros of the given polynomial. So let us assume that alpha is equal to 0 and beta is equal to minus 2 are the two zeros of the given polynomial. So now we have to find out the relationship between the zeros. That is the first one, sum of the zeros. This is in the form of alpha plus beta is equal to, we know the value of alpha beta here. So alpha value 0. So plus of beta value minus 2, then is equal to minus 2. Now product of the zeros. So that is equal to, in the form of alpha beta is equal to alpha value 0 and beta value minus 2. So this will become a 0 here. So this is the relation between the zeros of the given polynomial. Now let's come to the another polynomial. So that is fifth one. So in fifth one, given polynomial is here t square minus 15. So that is equal to, here we have to write the t square minus 15, that is implies. So by using the formula that is here, so a square minus b square is equal to a minus b into a plus b. So here t square minus root 15 whole square. So 15 we have to write as a root 15 whole square. So by using this formula, here a is equal to t, b is equal to root 15. So that is equal to, we get, after using the formula, that is t minus root 15 into t plus root 15. So now we have to equate to 0, that is t minus root 15 is equal to 0 and t plus root 15 is equal to 0 here. So now here t is equal to, so plus minus root 15 became a plus root 15 after moving on right side, and here plus root 15 became a minus root 15 after moving on right side here, that is minus root 15. So from this information, therefore, so root 15 and minus root 15 are the zeros of the given polynomial. For this, let us assume that alpha is equal to root 15 and beta is also, so beta is equal to root 15 here. So minus root 15. For this, what we have find out means, we have to find out the relation between the zeros. So that is implies first one, that is sum of the zeros. So this is in the form of alpha plus beta. So we know the values of the alpha beta here, that is root 15. So beta value minus root 15. So plus root 15 minus root 15 get cancelled here. So we will get is equal to 0 finally. And here product of the zeros. So product of the zeros, that is alpha beta, is equal to, so root 15 into minus root 15 is equal to here, that is equal to minus 15. So this is the relation between the zeros of the given polynomial. Now let's come to the final one. So that is sixth one. In sixth one, the given polynomial is, so given polynomial, that is 3x square minus x minus 4 here. So that is equal to, so here 3x square, so here minus x we have to write as a plus 3x minus 4x minus 4. So from next step we have to common the common terms in it. So in two terms we have to common the 3x, then we will get here, so 3x plus 1. So here, so in these two terms we have to common the 3x, then we will get x plus 1, and again in these two terms we have to common the minus 4, we will get x plus 1. So again x plus 1, so the remaining is 3x minus 4. So now we have to equate these two values to 0, then we will get, so x plus 1 is equal to 0, and next one 3x minus 4 is equal to 0 here. So x is equal to minus 1. So 3x is equal to 4. That is implies x is equal to 4 divided by 3. So therefore from this information here, -1 and 4 divided by 3 are the zeros of the given polynomial. So now let us assume that alpha is equal to -1 and beta is equal to 4 by 3. So for the relation is first one, sum of the zeros. So this is in the form of alpha plus beta is equal to alpha value is -1 and beta value plus 4 by 3. So this will we get, so LCM is 3. So -3 plus 4, that is equal to 1 by 3 here. So now product of the zeros is product of the zeros. So this is in the form of alpha beta is equal to here alpha value -1 and beta value 4 by 3, that is equal to -4 by 3. So this is the relation between the zeros of the given polynomial, and these are the final questions answers to the given quadratic polynomials. I hope it will help for you. Thanks for watching.